footing. In this video, you will understand the problem statement, and do the initial calculations, so that you can proceed with the design in the software. This is the problem statement for design of the trapezoidal footing, having two columns. The columns are named column 1, and column 2. The dimensions of column 1 are 350 by 350 mm, and that of column 2 are 550 by 550 mm. The dead loads, acting on the footing center through the column axis, are 500 kN and 800 kN, respectively. The live loads are 250 kN and 400 kN, respectively. You have to use reinforcement bars of diameter 20 mm. The safe bearing capacity of the soil underneath is 200 kN per meter square. The materials to be used are concrete of grade M30, and reinforcement bars of grade HYSD 415. Consider an allowable settlement of 1 cm. The length of the trapezoid is restricted to 4 meters. It is because of this space constriction only, that you are designing a combined footing. The spacing between the columns is restricted to 1.5 meters. This is the spacing between the columns, extending from the superstructure. Now let us do the initial calculations. As explained before, the footing area is given by the total load by SBC. The total load of the two columns on the footing is 500 plus 250 plus 800 plus 400. Thus the minimum area calculated is 9.75 meters square. Now, the formula for area of a trapezoid is given by A plus B, L by 2, where A and B are the lengths of the two parallel sides, and L is the perpendicular length between them. Now this length L is restricted to 4 meters, as mentioned. Thus, if you replace L with 4, and equate this formula with the area that you have found, you will get A plus B equals 4.875 meters. Mark this equation as equation 1. Now, if you look at the plan of the trapezoid, the two columns will be placed side by side, as shown. Obviously, the smaller column will be at the narrower side, and the larger column at the wider side of the trapezoid. The elevation view of this trapezoid is displayed, where C1 and C2 are the two columns, placed 1.5 meters apart, and the total length is 4 meters. XA is the distance of column 1 from the left edge, and XB is the distance of column 2 from the right edge. Let us consider XA is equal to XB. Then the length of XA and XB each will be half of the remaining distance, that is 4 minus 1.5, divided by 2. Thus XA and XB equals 1.25 meters each. Now consider an equivalent load W, acting as a reaction to the two loads W1 and W2, on the columns C1 and C2 respectively. This W will act at the center of gravity, along the length of the trapezoid. The reaction W should be the same as W1 plus W2, due to force balance. Similarly, the moments on the footing should be balanced. So, we will use that to calculate X bar. Consider the distance of the center of gravity, from column 1, as X bar. Now taking moment about the center of column 1. W2, the load on column 2, multiplied by the spacing between the columns, is equal to W, that is W1 plus W2, multiplied by X bar. Thus, rearranging the equation, X bar equals W2 into spacing, divided by W1 plus W2. W2, that is the total dead and live load on column 2, equals 1,200 kN. The spacing between C1 and C2 is 1.5 meters. And W1 equals 750 kN. Thus X bar equals 0.92 meters. This X bar is the distance from C1, and not from the leftmost edge of the trapezoid. The total distance from the side A is XA plus X bar. This is the distance of the center of gravity, from the left side. By formula, the distance of the center of gravity from the left side A, along the length of the trapezoid, is given by A plus 2B, by A plus B, multiplied by L by 3. XA equals 1.25 meters, X bar equals 0.92 meters, and the length L equals 4 meters. Replace the values in the equation. The resulting equation has two unknowns, a and b. Mark this equation as equation 2. Thus, solving the two equations 1 and 2, you get a equals 1.85 meters, and b equals 3.02 meters. We will approximate a as 2 meters, and b as 3 meters. So this is the footing you will be designing. The two columns are placed as shown. The length of the smaller parallel side is 2 meters. The two column centers are each at 1.25 meters distances from the left and right edges respectively. And the spacing between them is 1.5 meters. The length of the longer parallel side is 3 meters. Now to draw this trapezoid in the software, you will take the help of equally spaced grid lines, as the software does not have a trapezoidal footing as a preset. In the grid system, you will locate the four corners of the trapezoid, and join them to form the close figure. The safe bearing capacity of the soil is 200 kilonewtons per meter square, so the resulting subgrade modulus is 2 times 10 to the power 4 kilonewtons per meter cube. For the width of the design strip, the x-directional length is 4 meters, and the lengths in the y direction are 2 meters and 3 meters. Considering the smallest length of 2 meters, the width of the strip is half a meter. Using these calculated values, you will design the trapezoidal footing in the SAFE software, in the next video. Thanks for watching.